Hi, Algebra class. Good to see you this morning. We are going to continue our study of graphs and functions, and this should remind you of something that you did a long time ago. It has to do with skip counting. We call it arithmetic sequences. So we're on lesson 5. Get your definitions out, your paper, page 24. In the native language clues, I want you to give examples. That's what I want you guys to do as far as for that native language clue. So don't mark it out, but I want you to give a number example of each after you give the definition. So I'm going to go through this list pretty quick, and then I'll give you some examples that I'm going to show you in class, and then you can make up your own as we go. So let's take a look at the first one. The first one is a sequence. And you should know this in literature class because a sequence is a sequence of events. So in math speak, it's a list of numbers in a specific order. So when you want to list numbers greatest to least or least to greatest, you want all the factors of 2, you want all the factors of 10, that would be a sequence. So you have a specific purpose for the list of numbers. Next definition, term of a sequence. Well, you should understand from algebra that a term is what is separated by the operation. So the term in a sequence would be just any number that would be in between the commas in your sequence, or any number in the order that you've put them in. So you might go ahead and use in your native language clues in that box, you may write the same sequence down and then circle what the term is. So term is just a number. It's pretty simple. Next definition is arithmetic sequence. So an arithmetic sequence is a pattern in which each term after the first is found by adding a constant or a common difference, which would be D, represented by D, to the previous form. And really in regular language, that's just skip counting. You can count by twos, 2, 4, 6, 8, 10. And what they're talking about is the pattern in which each term after the first is found by adding a constant. Well, your constant is going to be plus 2, plus 2, plus 2, plus 2. We've done a lot of that with our function tables where we find the pluses on the X and we find the pluses on the Y so that we can find that arithmetic sequence. So make sure that you have a really good example for that. You have a lot of experience with that. And finally, common difference. This was referred to up above. It's also the difference between consecutive terms in an arithmetic sequence. In other words, it's what are you adding by? What's the common difference between the second number and the first number? How do you get from the first number to the second number? That is what we call common difference. Make sure that you take really good notes. Make sure that you give a really good example. And hopefully this is going to help you. So I'm going to go ahead and we're going to give you some real life examples now. I'm going to go into some explore and develop. Here's a good way in this first example. This is a really good way in identifying arithmetic sequence. You guys have a whole lot of experience with this. So you should be able to get some examples for this out of sequence, term of the sequence, arithmetic sequence, and then the common difference. All 4 of these you should be able to use the same example. So I'm going to wait just a second, and this is their example. They're using the pattern 17, 14, 10, 2, and 3. So it's not a simple pattern. They're not using 2, 4, 6, 8, 10. So what you need to determine, what you need to find out is we need to find the common difference between 17 and 14. So how do we get from 17 to 14? Let's make that 4 a little bit better. So that's your question. Hopefully, what you have found in this, to get from 17 to 14, you have to subtract 3. And then in your next pattern from 14 to 10, you have to subtract 4. And then in your next pattern from 10 to 7, you subtract 3 again. And then finally, from 7 to 3, you would subtract 4 again. So that's your pattern for this very first one. Hopefully, let's go ahead and make this a little bit better. There we go. So you go from 17 to 14, minus 3, then you go minus 4, then you go minus 3, then you go minus 4. Hopefully you are determining that this has an unusual pattern. Okay, so hopefully you've noticed in this first one, the common difference between 17 and 14 is negative 3. And then the common difference between 14 and 10 is negative 4. And then the common difference between 10 and 7 is negative 3. And then finally, we have a negative 4. Hopefully you've noticed that down here, this kind of tells you this does not have a common difference that's consistent. And that's how you can tell the difference between something that is an arithmetic sequence and something that is not. So in this example, this is not an arithmetic sequence because there is no common difference. Let's go ahead and take a look at our fractions down below. We need to distinguish if this also has a common difference. And of course, with fractions, remember you need to have a common denominator to make comparisons. Hopefully, you can relate this to money. In the very first one, it's negative 1.5. So how would you get from negative 1.5 down to 3/4? Well, I know that you can subtract 3/4 to get from negative 1.5 to negative 3/4. You just subtract 3/4. 3/4 and 3/4 is 1.5. And then take a look at the common difference between negative 3/4 and 0. This one you don't have to do any converting because all you have to do is you have to add, I'm sorry, it's not subtracting because they're negative numbers. You would have to add 3/4 to it. Negative 3/4 and positive 3/4 would also be 0. So you should be able to identify fairly quickly that this one does have a common difference. So this is an arithmetic sequence. So each common difference is plus 3/4. And then, of course, let me change that 3 to 4. Sorry about that. And then 0 to 3/4, you also add another 3/4 as well. So that's how you identify if something is an arithmetic sequence or not. First of all, you look at the sequence of numbers. You look at each term of the sequence. So in the first one, I looked at 17, which is a term, and 14, which is a term. In the second one, I looked at negative 3/2 and negative 3/4. Then I determined if there was an arithmetic sequence pattern. The first one was not because there was not a consistent common difference. The second one was a yes because it did have a common difference. Hopefully this helps you out. Make sure that you give a mathematical example in the native language clues in the middle, and then make sure that you get your definitions. Make sure you also into your yellow folder so that I don't have to look for it.